Hello everyone, welcome back to Cambridge Guru once again. As you know that we are doing AP Calculus course, and the very first unit that we are doing is pre-calculus review, and we have already done 2 units in the first, not the 2 units, 2 lessons, 2 videos we have already done. In the first video I introduced about the number system, and the last video was about the functions, in which we talked about the types of functions, various types of mappings, and how to determine whether a relation between two sets is a function or not, in which we did the vertical line test, right? We also did the horizontal line test to find out whether the function is many one or not. Okay, and we did, I think, 1 or 2 couple questions also. So this is the continuation of the previous lesson, in which we will talk about more about functions, because function is a very, you can say, the building block of calculus, right? So next topic, without wasting any time, let us start, which is even and odd functions. So what do you mean by an even function? Even function. So if I say that there is a function fx, right? So for any function fx, okay, I'm denoting the function in x, fx, if, what is the definition of an even function? That if f of minus x is equal to fx, right? Meaning is that if I put, or if I give the negative value of the input corresponding to the positive input, I mean, let us say you are defining f2, some output for corresponding to an input 2, and then f of minus 2, meaning what is the value of the function at x equal to minus 2. So if those two values are coming out to be equal, right, so then we say that the function is an even function, and this has to be true for every value, or for every x which belongs to the domain of fx. Okay, this symbol I introduced you in the number system, and the notations that I think various kinds of notation that we will use. So this symbol stands for belongs to. Okay, so if f of minus x is equal to fx, then we say then fx is an even function. Fx is an even function. Okay, example number 1, you can have the function fx is equal to, let us say, x square. Okay, this is simple. This is a simple quadratic function, simple polynomial function of degree 2. So how we can determine that whether this is an even function? There are 2 ways in which you can determine. First way is algebraic, in which that if I put f of minus x, okay, so minus x means wherever x is written in the definition of the function, you replace that by minus x. So you put this as minus x whole square, okay, because the function is squaring the input. This time the input is minus x, so it is squaring the negative input, so it is coming out to be x square minus minus will become plus, which is actually fx. So in this, you can say that f of minus x is coming out to be x square, which is equal to fx. So we can say that fx is an even function. Okay, this is example 1, you can say. Second example could be any polynomial function. Just like this is a polynomial function, you can take any polynomial function whose degree is an even number. What I mean to say is that if fx is equal to x raised to power n type, where n is an even number. Okay, so in this case also, you will have, or this function will be an even function, right? So in this case, this is, if n, for n equal to 2, we have already done the case, which is our example number 1. But if n is 4, so x raised to power 4, x raised to power 6, x raised to power 8, and so on. All these functions, all these polynomial functions will be even functions, right? Okay. And third example you can also have, if you have studied, of course, you might have studied this, all these trigonometric functions. Okay, we will do this trigonometric functions later on in this chapter, right? So for now, you must have known the cosine function, sine function, and tan function. Okay, I'm not going into the domain of this, but if fx is a cosine function, then this cos x is also an even function, right? Meaning is, because you must also know this, that a cos of minus x is in fact cos of x. Okay, I think you already know this. Cos of minus x is cos x, and if you do not know, the reason behind this cos of minus x is, so minus x in this case, this x is an angle, whether it is in radian or degrees, that doesn't matter. But if angle is negative, meaning is you are going clockwise. Okay, so if you are going clockwise, meaning is you are in the fourth quadrant. Okay, let us say this x is not in the fourth quadrant, but if x is between 0 and 90 degree and you are moving clockwise, that means the angle, that acute angle will be negative. Okay, so now you are in fourth quadrant. For example, let us say x is 30 degrees. Okay, so minus 30 degrees is cos of minus 30 degrees, meaning you are in fourth quadrant. Now, as we know that in the fourth quadrant, cos remains positive, that's why answer will be positive. That's why we say that cos of minus x is equal to cos of x. So whatever the value of cos is at 30 degrees, same value of cos will be at the negative 30 degrees. So we can say that cos is an even function. Okay. Another way to look at the even function is, which is very interesting, about the graphs of the even function, right? So if I take the example 1, so in example 1, this is our quadratic function, which is in fact a parabola. Okay, so this will be like this, a u-shaped curve. Okay, this is x square. Similarly, all these even power function will again be a u-shaped curve. Why? Because for negative x also the graph will remain same, whatever is the shape of the graph in the positive x. Okay, and this is the property that we will later on define in few minutes, right? So the graph of all these functions, x to the power 4, x to the power 6 and 8, will again be u-shaped, but we won't call this as a parabola. Okay, this is not a parabola, but yes, it will look like a parabola because shape is u. Okay, shape is u shape, but all u shape curve are not parabola, right? So it is a u shape curve, but these are not a parabola, but again these are even functions. Okay, and lastly, you must have known this cos function, graph of cos function. So this is your coordinate axis, right, like this, and graph of cos starts from 1, because for 0, cos 0 is 1, so the graph is like this till 360 degrees. And if we take the negative values, so graph of cos will go like this. Okay, so as you can see here, in all these three graphs, you can see that all these graphs are symmetrical about y-axis. Meaning is that whatever is the shape of the graph towards the right of this y-axis, the same shape is towards the left of the y-axis. Okay, you can see in the cos graph also, like this, right? So this is an important property for all the even functions, that the graph of an even function is symmetrical about the y-axis or the vertical axis. Okay, symmetrical about the y-axis meaning is that y-axis always acts as a mirror. Okay, so that's all as far as even function is concerned, and similarly we can define the odd function. So it is just the opposite of even function. So how you will define the odd functions? So odd functions are that for any function fx, if you find that f of minus x is, this time it is not equal to fx, in fact it is minus of fx. Okay, if you are giving the negative input, you are getting the negative output corresponding to positive input and positive output. So if x is the input, output is fx, but if minus x is the input, then it is reversing the output. Okay, so minus of fx, reversing in the sense sign is negative. So for all x that belongs to the domain of fx, then fx is out. Right, and example are very easy. That for the even function, we took the polynomial function with degree as even number. In the odd function, you will start with the odd number. Okay, so the very basic function, you can start with fx equal to just x, a linear function which is a straight line. Okay, and because if you put x as minus x, so output will be minus x. Okay, second example you can take as fx equal to x cube this time. So if x is minus x, means input becomes negative. So f of minus x, according to the definition of the function, what is the definition? That it cubes the input. So you have to cube the input, which is negative x this time. So you will get the minus of x cube, which is in fact negative of the original fx, which is x cube. So this time f of minus x is minus of fx. So we say that fx equal to x cube is an odd function. Similarly, for any polynomial function with the odd degree, odd power will be an odd function. Okay, and just like we took one example of a trigonometric function, so is there any trigonometric function which is odd? Of course it is, which is the complementary of cosine function, which is the sine function. So fx is sine x. So what the negative input does to this sine x, that if you give negative inside the sine, you get the negative of sine x. Okay, so sine of minus x is in fact minus sine x, and applying the same logic, that if the angle is in fourth quadrant, so here in the fourth quadrant signs remain negative. So if you give the negative input to sine, meaning you are in the fourth quadrant, output will be minus of sine x. Okay, so sine x is an odd function. Now talking about the graphs of all these odd functions, as you can see that the graph, as you already know, that for the first example fx equal to x, it's a straight line which is passing through the origin, having the gradient as +1. Okay, so if this is your coordinate axis, so graph of fx equal to x will be a straight line like this. Okay, now you have to look through the graphs of this, and I will suggest that you pause this video and try to draw the graphs of fx equal to x, x cube and sine x, and analyze that whether is there any symmetry about the graphs, or the graph is a reflection about certain points, certain lines, certain axes. This you need to analyze. Okay, so pause this video and just do this, and I'm continuing with this. So sketching the graph of x cube, next example. fx equal to x cube goes like this and like this, right? Meaning of this is that if, let us say, x you take as my plus 2, so for x equal to 2, output is plus 8, right? So for x equal to 2, let us say this is 2, output you are getting as plus 8. But if x is minus 2, output you are getting as, you will get as minus 8. Okay, so this point, as you are increasing from 0 to 2 like this, you will decrease from 0 to minus 2 like this. Okay, so there is certain symmetry in graph of odd functions also, right? Now let us talk about sine function. Okay, so graph of sine x looks like this, that it starts from 0, it goes from pi to 2 pi, and in the negative direction it goes from 0 to minus 2 pi like this. Okay, and as you can see that you are increasing in this direction in the negative x, means if you give the input as negative, it will decrease like this. Okay, but the course of movement will remain same. Course in the sense that if you are increasing in this fashion, you will decrease in this fashion. It's a simple. Okay, so if you flip this curve from, or let us say rotate this by 180 degree, you will get the same curve. Now talking about the symmetry of this function, of all these odd functions, you can see that whatever is the portion of the graph in the first quadrant, in the sense not exactly the first quadrant, but for positive values of x, the same is reflected in the y-axis. Not in the y-axis, in the x-axis, but in the opposite quadrant. Okay, so it is symmetrical in the first and third quadrant. Here also it is increasing like this and it is decreasing like this. So it is again symmetrical in first and third quadrants. Okay, similarly for sin x, it is like this, it is like this. Okay, so we won't say that it is symmetrical in first and third quadrant. It doesn't make, it is not a correct mathematical statement. So we will say that the graph of an odd function is symmetrical. We say it is symmetrical about the origin. It is symmetrical about the origin. Okay, so these two facts you should know about even and odd functions. That's it. Next topic I'm going to talk about is the transformation of functions. Okay, as you can see that this we have done even function, it is symmetrical about the y-axis, and for x cube it is symmetrical about the origin. Okay, if it is an odd function, this we have done, right? So next we will talk about the transformations of functions. Now in transformation of functions, there are various types of transformation. One transformation is your what we say is translation. Translation means you are moving the graph either in the positive direction of y or x-axis, or in the negative direction of y and x-axis. Means you are just moving the graph either horizontally, meaning towards the x-axis, along the x-axis, or you are moving the graph vertically or along the y-axis. That is the meaning of translation. You are translating the graph. You are not deforming any its shape. Okay, shape will remain same. What you mean by shape is that you are neither compressing nor you are stretching the graph. Okay, shape will remain same. You are just moving the graph either like this or like this. This is called translation. So mathematically, how this is done in functions. So let us take one example, that if let us say example let, and I will take this common example which is our quadratic function fx equal to x square. Okay, graph of this fx equal to x square looks like this. Again a u-shaped curve, parabola, right? This point is 0. Right now, simple thing is that if you put x equal to 0, you are getting y as 0, y mean value of the function. If I put x equal to 1, function is 1. If I put x equal to 2, function is 4. If I put x equal to 4, function is 16, and so on. Right? Let us say that if I modify the definition of function, let gx is defined as x square plus 2. Okay, so as you can see, there is a plus 2 in the definition of the function. So what this plus 2 does is that it adds plus 2 to each output corresponding to each x input. So earlier when x was 2, value of function was 4. But this time, if x is 2, value of function will be 4 plus 2. Okay, so in the same function, this point is, let us say, 2, and this point is 4. In the modified graph, in the translated graph, which is gx, the value of the function at x equal to 2 will be 6 instead of 4. Okay, value of the function at x equal to 1 earlier was 1, but this time it will be 3. At x equal to 0, the value of gx will be 2. Right, so meaning is that instead the starting point to be 0, the starting point of the gx function will be 2. Okay, so as you can see that there is no change in the shape of the curve. It is just that the initial point has been shifted by 2 units towards the y-axis, and the resultant graph will be like this. The red function, the red graph, and this point is 2. Okay, starting point, the y-intercept of the graph is 2. It is shifted 2 units upwards, right? So as you can see, this 2 indicates how much it has been translated, and plus 2 in the definition of the function, right? This plus 2 indicates that you are moving 2 units in the positive y direction. You can note it here that it is in the positive y direction, right? Translated in the positive y direction. Okay, remember, we have not done any change in x. Here it was x square, here also it is x square. Okay, there is no change in x. Fine, this is called vertical translation in the positive. And if this plus 2 becomes minus 2, right, you can have another function hx is equal to x square, this time as minus 2. So again it will shift towards 2 units but in the negative direction. Okay, so this hx graph will be shifted downwards by 2 units. So this blue graph is of hx, this was fx, and this red one is your gx. Both gx and hx are the translated version of fx. Okay, so just pay attention to the definition of this translated function, how the translated graph along the y-axis looks like, how the function looks like. Okay, now this was translation about y-axis. What about the x-axis? Okay, so let us take another example. Example number 1 was this. Example number 2, we are doing translation in the x-axis, right? So let, again, if fx is x square, this is your x square function fx. Okay, and you take another function which is gx. So gx is equal to, this time gx is basically f of x minus 2. So instead of just x, now the input is x minus 2. So definition of this becomes x minus 2 whole square instead of x square. Now here you have changed the input. Now how this input is changed, this we need to find out, and how this will be reflected in the graph of fx. So simple thing is that in the initial value, initial in the sense, if I talk about fx equal to x square, at x equal to 0, you are getting the value of function at as 0. Okay, this was the origin. Similarly, for if I change the input for x equal to 1, right, you are getting value of fx as 1, and so on. But this time, same value, meaning you obtain the value of this gx as 0 when x becomes 2. Okay, when x becomes 2, now you get the value of the function as 0, right? So similarly, the corresponding value of the function which was initially f1, meaning that if x is 1, value of the function fx was 1. Now if we have to obtain the value of the function as 1, which function? Gx. This time you need to give the input, this x needs to be 3. Then only it will become 3 minus 2, which is f1. Okay, this I have written here, right? So this time you need to give the input as 3 to obtain the same value what you were getting at x equal to 1. Okay, so this time you will get at x equal to 3, right? Similarly, at x equal to 2, this time you will get the value of the function as 0. This is 2. Okay, so as you can see here, that earlier 0 value you are obtaining as 0, 1 value you are obtaining at 1, but this time you are obtaining the 0 value at 2 and 1 value as at 3, meaning each input has been shifted towards right by 2 units. I hope I am making sense and you are being able to understood that when this x becomes now 3, you will get the value of the function corresponding to x equal to 1. Okay, that means 1 has become 3, 2 has become 4, and 3 has become 5, and so on. So each input has been shifted towards right, meaning the whole graph has been shifted towards right by 2 units. So your translated graph this time will be this, that its vertex will now shift from origin to the point 2. Okay, this origin has been shifted to point 2 and each value has been shifted towards right? Now mathematically, how we can analyze, how we can say that it has been shifted towards right or left? Okay, so here is the opposite what was done in the y direction. This plus indicates positive y direction movement by 2 units, but in case of horizontal movement, this negative indicates positive x direction. Okay, and how we can analyze, how we can remember? By simple logic. Okay, the same logic that I have explained just now. The same value of the function you will obtain now when you put this x as 3 rather than minus 2. Okay, so that is how you will obtain or remember that this minus indicates plus direction, and again 2 units it has been shifted, that's why it is 2, right? And if this minus becomes plus, so that will be the negative x direction. Okay, so you take, let us say, hx. For hx, if it is f of x plus 2, okay, meaning x plus 2 whole square. Now in this case, your vertex, earlier for fx, vertex was at 0 and f0 was 0. So same 0 you will obtain when x becomes minus 2. That means the vertex has been shifted towards left. Okay, So this minus 2, this will be your gx. This graph is of gx, this is fx, and red one is not gx, I'm sorry, this is hx, and this is your gx. Okay, so remember, if we are moving towards x direction, plus means in the negative direction and minus means in the positive direction. So this was translation, right? Next type of transformation is what we say is stretch and compress. Okay, stretching or compressing, yeah, stretch or compress. Now what do we mean by this? Let us take the same very example. If fx is x square, and let us put this, or let us multiply this fx by 2. This gx is in fact twice of fx. So it is 2x square. Now this time we haven't added plus 2. What we did is we have multiplied the corresponding output with 2. Okay, we have not multiplied x as 2. Just remember this. X has not become 2x. If x became 2x, then that will be 2x whole square, which is 4x square. But this time it is 2x square. So remember that x square has been multiplied by 2. Okay, meaning each output has been multiplied by 2. Now how we can relate this to graph, how the graph will look like, and how we can say that which type of transformation is this. Let us analyze. So I would write here as fx, okay, and here I will write as gx. Here I will write value of x. So if x is, let us say 0, so value of fx was 0 and gx was 0. If x was 1, fx was 1 and gx will be 2. If x is 2, gx is 4, fx is 4, gx becomes 8. If x is 3, fx becomes 9, gx becomes 18, and so on. Let us plot these points and you will see the result. Right? So this is 0, this is 1, this is 1, this is 2, and this is 3. X equal to 1. Let us say this was our parabola. Okay, y equal to x square. This is at x equal to 1. Value is 1 at x equal to 2. This is 4. 3, it is 9. This was the value of fx. Now for gx, let us plot the graph for gx by red. At x0, it is 0. At 1, gx is rather 2. So this value has been shifted up by 2 units. Okay, I won't say it is shifted, it is multiplied by 2, because for 3 it is will be shifted by, you can say, 9 units. Okay, so it is not, shifting is not constant, right? So we won't say it is shifted. Okay, you will just say that it will get a jump. So this is 2 at x equal to 2. This is becoming 8. Okay, so this value is now 8. So as you can see that the graph of fx, not fx, graph of gx will look like this. Similarly, in the negative part also it will look like this. It will never cross your fx. Okay, because at the same input you are getting the more output, the increased output, because each output has been now multiplied by 2, though the input is remaining same. Okay, so the result in the graph is that the graph is compressed. The graph is compressed, or you can say it is stretched along the y-axis. Okay, it is stretched along the y-axis. Earlier you were getting at x equal to 2, you were getting fx value as 4. But now at this x equal to 2, the graph is stretched. You are getting 8 as the value. Similarly, at x equal to 3, you are getting earlier as 9, but this time you are getting 18. So you have stretched the graph along the y-axis. Okay, this is only possible due to this 2. You have multiplied the function by 2. Right? Now, opposite will be the case when you will divide this function by 2, or this constant is less than 1. This is also the case. Okay, whatever the constant you are multiplying with the function, if that constant is greater than 1, then we say that it is stretched, and if it is less than 1, meaning you are making the division. Okay, if I say you are multiplying the function by half, okay, so this is actually you are dividing the function by 2. Please do not get confused. Okay, so this, in this case, this will be the compress, not compress, it will be expand along the y-axis. It will expand along the y-axis. You will get lesser value corresponding to the previous input. Okay, so in general statement we will do later on. Okay, so this is stretch along y-axis. What about x-axis? Okay, so let us take another example. Example number 2, that our original function fx is x square, but this time you are multiplying x by 3. So this becomes 3x. So output is 3x whole square. It becomes 3x whole square, meaning 9x square. Okay, so do not open this as 9x square, because input is now 3x. Okay, earlier the function gx was 2x square. It was not written as root 2x square. It can be understood in terms of movement along the x-axis, but let us not go into more complication in this. Okay, so simply, as the statement is saying, that we have f of 3x as your gx, meaning is that now the function input is multiplied by 3, so corresponding to the definition, according to the definition of the function, it will come 3x whole square, which is 9x square. So let us not open it. So how the function will look like? Okay, so let us again make a table. Okay, this is your x, this is fx, and this is gx, which is actually f of 3x. So at x equal to 0, value of fx was 0, and at of 3x it will be 0. At x equal to 1, fx is 1, but this time gx will be 9. Okay, at x equal to 2, it will be 4, but it will be this will be 3 into 2, 6, it will be 36. Right, so as you can see here, we won't talk about as 9x square. As I told you earlier, you can say that it has been stretched by 9 along the y-axis, but we have changed the input x as 3x. Let us not do the algebra within the function. Okay, so we will understand this with respect to stretch or compress along the x-axis. So how we can do this? So this was your x square. Now understand this. If you need the value of the same f1, okay, let us do this explanation here, that your original function, you need the value of f1, which was 1. At 1, the value of function was 1. Now you have a function as f of 3x. So in order to get the same value of the function, which is f1, you need to make this 3x as 1. This will be possible when you give input x as 1 by 3. That makes sense. Then only this f will become this, you will get the value as f1. That means for each whatever value you are getting at x equal to 1, this time you will get at x equal to 1 by 3. At x equal to 1 by 3. So this value, same value will get at 1 by 3. So point will be like this. Okay. Similarly, if you do, let us say you need the value of f3. So to make this as x equal to 3, f3, you need x as 1. So earlier, the value of function at x equal to 3 was coming out to be 9. But same this 9, this time will come out at x equal to 1. Okay. So when you draw the graph of this, it will look like that the graph has been stretched along the y-axis by 9 units. But in case of x, we say it has been compressed. Okay. So how we will show this graph? If it is stretched along, if it is compressed along the x-axis, then rather than compressing the graph, we change the coordinates. Rather than compressing the graph, we change the coordinates. So the graph shape of the graph will look like y equal to x square. Okay, but this time we will change this 1 to 1 by 3. Okay, and whatever 3, we will replace this by 1. And at x equal to 1, this time you are getting as 9. At x equal to 1 by 3, you are obtaining 1. Okay, so it has been compressed along the x-axis. Okay, meaning is, if it is compressed along the x-axis, meaning it has been stretched along y-axis. But again, we are not doing with respect to y-axis only, because remember, we have not multiplied fx by 9. We have multiplied x by 3. So in the context of the input, we need to talk about. Okay, then only we will be able to change these coordinates of the x-axis. And how we are changing this? We are just dividing the each corresponding x by 3. Okay, so in a nutshell, there are 2 or 3 more. Let us do all those transformations again, and we will summarize all these transformations in a single slide later on. So next type of transformation is reflection. Okay, reflection, in this case, it will be along y-axis. Let us say along x-axis. So if you do the graph of example, let y is equal to x square. Okay, so this is y equal to x square, right? And if I multiply, let gx is equal to minus of fx, meaning minus of x square, meaning you have multiplied the given function by negative sign. So whatever are the values of y corresponding to each input, all those values will become negative. Okay, it is a kind of stretch, but that constant c is negative in this case. Okay, so basically, if you multiply any function by negative number, it will be reflected along x-axis. So each value will become negative. So at x equal to 1, if you are getting as 1, this time you will get at x equal to 1 the value as minus 1, and so on. So graph will be exact replica of fx, but it will be below the x-axis. Okay, so this is the reflection along x-axis if fx is multiplied by minus sign. Okay, we are not solving this equation. This is just a way to represent this reflection. And second kind of reflection is along y-axis, meaning if now the input is multiplied by negative sign. Okay. Let us say y is equal to x cube. If I multiply an input sign, if I multiply the input by negative, so your gx will be minus x whole cube, which will be minus x cube. Okay, so minus x cube is negative becomes positive, positive becomes negative. So x cube, this will be negative like this. So earlier, let me draw the graph of fx first. This was x cube. Okay, so if x is positive, now this becomes negative. Okay, so it will be reflected along the y-axis. So for x equal to 1, now this time x equal to minus, at x equal to minus 1, it will be positive. Okay, so it will look like this. Okay, so it is just a reflection along y-axis. Right, so simple thing is that if the input is multiplied by a negative number, not number, but just by minus 1, and it will be reflection along y-axis. And if the output is multiplied by minus 1, then it will be reflection along the x-axis. Okay, so all these are different types of transformations, and the summary of all these transformation is written here. So this is vertical and horizontal shifting, meaning the translations. So if y is fx plus c, it is shift c units upwards. If it is minus c, it shifts c units downwards. So this was your original fx. You can see the pointer here, right? If it is plus c, so it is shifted c units upwards. If it is minus c, it is shifted c units downwards. If you have to shift towards right, then input should be x minus c. So this is f of x minus c, and it has shifted c units towards right and c units towards left by representing this fx by fx plus c. So this is translation. Stretching and reflecting. So if y is c of fx, again y equal to fx is given, and it says that suppose c is greater than 1. We are talking about you are multiplying by any c which is greater than 1. If it is less than 1, then we will say you are dividing by a factor. Okay, so in the first case, you are multiplying any constant which is greater than 1, just like fx is equal to 2x. Stretch the graph of y equal to fx. So graph will stretch vertically by a factor of c. So as you can see, y equal to fx is here. It has been stretched like this by c factor along the y-axis. You have pulled vertically upwards. Okay, and second is 1 by c fx. It is compressed the graph of y equal to fx vertically by a factor of c. So it has been now compressed, this graph. You have compressed like this. If you are dividing and the given function by a positive constant, which is greater than 1. Then f equal to cx, it is compression and stretching along the x-axis. So it is cx, obviously c is greater than 1, so this is the compress. So remember, x and y-axis, the transformation along x and y-axis are opposite. Okay, if you are multiplying x with a greater than 1 number along the x-axis, it will be compressed. Along the y-axis, it was stretched. Please remember this. Okay, along the y-axis, it was stretched. Along the x-axis, it is compressed. Both these things are opposite. Just remember. Okay. Similarly, if you are dividing x by c, here it will become stretch. Earlier, if you are dividing, it will compress. And this we have done. Y equal to minus fx, it is reflection along the x-axis. Y of minus x, it is reflection along the y-axis. Okay, having said all these transformations, let us do a couple of questions in this. So given the graph of y equal to root x, we have to use transformations to draw the graph of all these given functions. So let us draw the graph of root x. I'm just taking root x for all the positive values in order to define this to be a function. Okay, so this is your, let us say, root x. Fine. Let me stretch this to negative also, because they are, I think, negative transformations. Okay, fine. Now first one is root of x minus 2. So root of x minus 2, again it is a transformation along. Just pause this video and sketch your graph with yourself. So root of x minus 2 is that it will translate in the negative y direction by 2 units. So starting point earlier was 0, this time it will be a minus 2. Okay, so it will go like this. Okay, remember this is just a sketch, this is not a plot. What is the difference between a sketch and plot? Sketch is not that exact. Plotting is by plotting to each and every point. Okay, so second one is x minus 2 root. Now this time the transformation is done in the input. It is just like x plus c or x minus c. You have translated the input. So the effect of this in the graph will be, if it is minus 2, it will be translated in the positive x direction by 2 units. Okay, so this graph will be shifted towards right. Okay, I don't know exactly what this value will be. You can say, okay, root of x minus 2 at x equal to 4. This value actually will be 4. Okay, because at x equal to 4, you will get x as 0. Right, so the point 2 will be in the middle of this. Let us take this as 2. So it will shift 2 units towards right. Okay, shape will remain same. Let us call this as what should I call? It is gx. This is hx. This is gx. Okay, third one is y is equal to minus of root x. So it is just a reflection along the x-axis. Okay, x-axis, because each y has become negative. This negative is not inside the input, inside the root, then input will become negative. But this time it is outside the root x sign, so it is multiplication of minus 1 by 2 the y. So it is reflection along the x-axis. So reflection along x-axis will be like this. Okay, let us call this function as ix. Okay, and fourth one is y equal to 2 root x. 2 root x is simply the stretch along the y-axis. You have multiplied the function by 2 units, so it's stretch along y-axis by 2 units. So it will be like this. Okay, just stretch it. Y equal to 2 root x. Let us say this is jx. And lastly, it is y of minus x, again with the red sign. Y is equal to minus root x. So now input has becomes negative. It is the reflection along the y-axis. So it is just a reflection along y-axis. This is kx. Okay, so all these 5 graphs have been drawn. All right. Example number 2 says, sketch the graph of the function y equal to mod of x square minus 1. Okay. This modulus won't let you live easily. Okay. So solution is, I should start with the very basic function y is equal to x square, as you can see. Okay. So this is your this is 0 and this is your y equal to x square. Okay. The next term is, what we have done here is x square, we have done minus 1. So next transformation is that it has shifted downwards by 1 unit. So now this has become like this, something like this. Okay, 1 unit towards negative y-axis, this is minus 1, this point. Okay, now last thing that you have done here is you have taken the modulus sign. What modulus sign does is that whatever the graph is below the x-axis, it changes that those negative values to the positive values. Graphically, graph which is lying below the x-axis, that comes above the x-axis, that portion becomes positive. That is the meaning of modulus. Otherwise, for other values where the graph is positive, it will remain positive. Okay, so the function of modulus function is to make the negative into positive. Okay, so this portion of graph which was negative from this point to this point, it becomes positive. How it becomes positive? It is just a reflection. Okay, so it will go like this. Okay, so final graph will be like this. Okay, this negative portion becomes positive and this was plus 1. Now this was minus 1, so it will become plus 1. This is mod of x square minus 1. Okay, so that's all for today. I think you have learned something in the transformation. Please pause this video wherever you want to, because it has been, I think, almost 1 hour. So that's all for today. See you very soon with the next lecture. Take care. Bye bye.